Good morning. I'm Navneet Kaur Randhawa from GPC Amritsar. Today I'm here to present the lecture of Input Output Organization. So in today's lecture I'll explain the following topics. First one is the Input Output Organization. Then second is Input Output Interface, asynchronous data transfer, asynchronous serial transmission. There are the different data transfer modes. So first is the programmed input output, second is interrupt initiated input output, and last is the direct memory access, that is the DMA. So first of all, what is input output organization in computer architecture? The input output organization of a computer system is totally dependent upon the size of the computer and the various peripheral devices which are connected to it. So the input output subsystem of the computer system provide the efficient mode of communication between the central system and outside the world. So in computer architecture, the input output organization of the system is depends upon the size of the computer system which is we are using and the various peripheral devices which are connected with that particular computer system. There are various peripheral devices which are used. The most common input output devices are monitor, keyboard, mouse, printer, magnetic tape. In these peripheral devices, the monitor and the printer are the output devices which is used to get the out from the computer system, and keyboard and mouse is the basically input devices which is used to giving input to the computer system from the user side. Magnetic tape is the storage device which is used to store the information. So these devices which are the direct under the control of the computer are said to be connected online. Now why we require the interface, or we can say the interface unit is very important so that we can connect the computer processor and the peripheral devices. So input output interface provide a method for transferring the information from internal storage and the external input output devices. So the peripheral connected to the computer need a special communication link for interfacing with the central processing unit, which is the processor. So interface unit is basically the device which is used to connect the computer system processor and the peripheral devices, because there are lot of difference between the peripheral devices and the computer system. So the purpose of communication is to resolve the differences that exist between the central computer and the peripheral devices. So what are the main differences that are basically between the computer systems CPU and the peripherals? So the major difference, the first one is peripherals are electromechanical and electromagnetic devices, and the CPU is the or the memory is the electronic devices. So the conversion of signals values may be needed. So for that purpose we require some another unit which is basically used so that we can convert the signals. Second difference is the data transfer rate of peripheral is lower than that of the data transfer rate of a CPU. So there must be some synchronization needed. So the synchronization mechanisms is also needed. So that's why we require some another unit which provide that synchronization. Third difference is the data codes and the formats in the peripheral differ from the word format in the CPU and the memory. The last difference is operating mode of the peripherals are different from each other and must be controlled not to disturb the operation of the peripheral devices which is connected to the CPU. There are a lot of peripheral devices are connected to the particular computer system. Uh, some of them are used for input purpose, some of them are used for output purpose, some are storage devices. So the working of peripheral devices is depend upon the interface unit so that they independently do their work and not disturb the working of some another peripheral devices. So to resolve all these differences, the computer system include a special hardware components between the CPU and peripheral. That particular unit is known as the interface unit. So the interface unit is to supervise and synchronize all the input and output the transfers, and it is provide the interface between the processor bus and the peripheral devices. Now the next topic is input output bus and interface module. It defines the typical link between the processor and several peripherals. The processor is connected with the peripheral devices, though there are some input output buses. So input output bus consists of data line, address line and the control lines. So the input output bus from the processor is attached to the all peripheral devices. So to communicate between with the particular device, the processor places a device address on the data line and data on the data bus. So each interface decodes the address and control received in the input output bus, interprets them for the peripherals and provide the signals for peripheral controller. Here is the most important thing: the overall controller is there, but the peripheral devices have their own controller. So the peripheral devices is synchronize and the data flow and supervise these data transfer between the peripheral and the processor. Suppose we are using a printer, so the printer has their own controller. So the each processor has its own controller. Processor, suppose we are using printer, and printer controller controls the paper motion and print timing. The control lines which are used, that are referred as the input output command. So there are four commands: control command, status command, input data command and output data command. First is control command. What is control command? Control command is issued to activate the peripheral and to inform it what to do. Second is status command. Status command is used to test the various status in the interface and the peripherals. Third is output data command. The data output command is basically interface to respond by transferring the data from the bus into one of its register. So fourth and last is input data command, which is opposite to the output data command. So in this case, interface receives the data from the peripheral and place it in its the buffer register. So these are the input output commands which is used in interface. Now this is the detailed diagram of the interface, in which the processor is connected with the various peripheral devices. Here the keyboard, printer, magnetic disks are the peripheral devices. They are not directly connected with the processor. They are connected through some third unit which is called the interface unit. So interface resolve all the differences which I explained earlier between the processor and the peripheral devices. So there are the three input output commands, that is data, address and control lines. So these are the lines which is used in this. So this is the diagram of connection of input output bus to the input output devices. Next topic is input output versus memory bus. To communicate with input output, the processor must communicate with the memory unit. Like the input output bus, the memory bus also contain the data, address and read write control lines. There are three ways that bus can be used to communicate with the memory and input output. So the first is use two separate buses, one for memory and another for input output. Second is use one common bus both for memory and input output, but separate control lines for each. Third and last is use one common bus for memory and input output with common control lines. Suppose we considering the first method, that is the computer has an independent set of data, address and control buses, one for assessing the memory and another for assessing the input output. So this is can be done that provides the separate input output processor. So the purpose of input output processor is to provide an independent pathway for transfer the information between external device and internal memory. Next topic is asynchronous data transfer. As we know, there are two type of data transfer: synchronous and asynchronous. Synchronous means the two units, that is source or destination, are synchronized by some common clock pulse. But in case of asynchronous, the two units are not synchronized by some common clock. They have their own private clocks. So this scheme is used when the speed of input output devices do not match with the microprocessor and timing characteristics of input out devices is not predictable. In this method, processor initiates the device and check the status, and that means CPU has to wait till the device is ready to transfer the data. When data device is ready, CPU issue instruction for input output transfer. So in this method, two types of techniques are used based on the signal before data transfer. One is strobe control and second is handshaking. So now the first topic is strobe signal. This method is asynchronous data transfer which use single control line to the each transfer. This is activated by either by the source or by the destination unit. This is the first case of strobe signal, that is data transfer initiated by the source unit. Here two units are available. One is the source unit and second is the destination unit. Source transmit the data by the data bus and also a strobe signal is sent by the source to the destination. Here data is sending, that means data is valid, that is sent through the data bus, and the strobe signal is remains activated up to the destination is have to receive the data. So this is the source initiated strobe signal for data transfer. In the first diagram, that is the first diagram, the data bus carries the binary information from source to destination. So the bus has multiple lines to transfer the entire byte or the word. The stop signal that informs the destination unit when the valid data word is available on the data bus. Those second means the timing diagram, which is the source unit first place the data on the data bus and the information on the data bus, and the stop signal remain in active state to allow the destination unit to receive the data. This is the first case, which is data initiated by the source unit. Now the second case is data initiated by the destination unit, because here the initiation is started from the destination, so stop signal is sent from the destinations to the source. In this, the source unit is there and destination data is sent by the source to the destination and by the data bus, and stop signal is sent from the destination to the source unit. Same in the timing diagram. So in this method, the destination unit activates the stop pulse and to informing the source to provide the data. This source will respond by placing the requested binary information on the data bus. The data must be valid and remain in the bus long enough for the destination unit to accept it. When accepted the data by the destination unit, then it will disable the stop signal and source unit removes the data from the data bus. So this is the two methods which is using in the stop signals. One is the by the source unit and second is the by the destination unit. There are some disadvantages of stop signal. So the main disadvantage is that source unit initiates the transfer, has no way of knowing whether the destination unit has actually received the data item that was placed in the bus. So similarly in case of the destination unit, suppose destination unit initiates the transfer, has no way of knowing whether the source unit has actually placed the data which is required by the destination unit, placed that data particularly on the data bus. So these are the disadvantages which is in this particular method. So these disadvantages is removed by the another method, that is the handshaking method. So the next method is handshaking. Handshaking method solves the problem of stop, which is solved by introducing the second control signal that provides a reply to the unit that initiates the transfer. Suppose we considering the data initiation by the source unit, so a reply is given by the source unit. So the every unit have some information that which is not given in the stop signal. Suppose we considering the source or we considering the destination, so in the handshaking method the such problem is not occurring. Now the principle of handshaking, two wire handshaking methods is used in this. So the one control line is in the same direction as the data follows in the bus from source to the destination. It is used by the source unit to inform the destination whether there is a valid data in the bus or not. The another control signal is in the another direction, that is from the destination to the source side. It is used by the destination unit to inform the source whether it can accept the data or not. The sequence of control during the transfer is depends upon the unit that initiates the transfer. So the two cases which is available in the last control signal, the same cases are considered in this method, that is the handshaking. So the first method is source initiated transfer using handshaking. So the sequence of events show the four possible states that transfer can be at any given time. The source unit initiates the transfer by placing the data on the bus and enable the data valid signal. Here the signals are used. So whenever the source initiates the transfer and send the data on the data bus, it enables the data valid signal. Then the data accepted signal is activated by the destination unit after it accepts the data from the bus. So after getting the data accepted signal from the destination unit, the source unit then disable the data accepted signal and system goes to the initial state, that is the from the starting, that is the data valid signal that is sent by the source unit. This can be explained by the diagram. In this diagram, source unit send the valid data by the data bus to the destination unit. Destination unit send a reply to the source unit, that is data is accepted or not. So this can be explained by the sequence of events. This is the sequence of events. So the source unit, which is the initial state in this case, place the data on the data bus and enable the data valid signal, and that signal is sent to the destination unit. Then accept the data from the bus. So the destination enable the data accepted signal and send to the source unit. That source unit disable the data valid signal and then it will given to the destination unit. So the destination unit simply accept the data which is sent by the source and disable the data accepted signal. Then that goes to the ready to accept the another data which can be sent in the next case. So that means the system is now goes to the initial state, that is the starting state. So this is the method, that is the source initiation by using the handshaking method. Now the second case is destination initiated transfer using handshaking. As the name resemble that it is started from the destination side, so initial state will be the destination side. So destination unit has to change the ready for data to reflect its new meaning. So the source unit in this case does not place the data on the data bus until it can receive the data or it receive the signal from the destination side, that is the ready for data signal. So the hands shaking procedure in this case follow the same procedure that is the in the case of the source initiated, but only the difference is in the source initiation and the destination initiated transfer is the choice of initial state. In case of source, the initial state is the source unit, but in case of the destination, initial state will be the destination unit. So in this diagram, the data is only sent by the source unit to the destination when it can send accept the signal from the destination side, that is ready for data signal, which is sent by the destination unit to the source unit. Now the sequence of events. In this particular event, the initial state will be the destination unit. So the destination is ready to accept the data and enable the ready for data signal and send to the source unit. In the source unit, the data is placed by the source unit on the data bus and enable the data valid signal. That signal is given to the destination and it will accept the data from the data bus and disable the ready for data signal. Then the signal is given to the data and data valid is signal is disabled by the source unit, and then it will goes to the initial state, that is the destination unit. So this is the destination initiation transfer using handshaking. The advantages of handshaking method. First is the handshaking scheme provides the degree of flexibility and reliability because of successful completion of data transfer is totally dependent upon the active participation of both of the units. So the second is, if any one of the unit is faulty, the data transfer will not be completed. Such an error can be detected by means of timeout mechanisms, which provides an alarm if the data is not completed within the time. So the timeout mechanism is managed by the internal clock by the computer system, which gives the alarm if the particular data is not received within the particular time. So these are the advantages of handshaking method. Next topic is asynchronous serial transfer. So serial transmission means we have to send the data in the sequence wise. So the transfer of data between the two units is serial or parallel. In parallel data transmission, the n number of bit messages must be transmitted through the n separate conductor path. But in case of the serial transmission, each bit in the message is sent in sequence only one at a time. As we know, parallel transmission is fast, but it requires many wires, so it is more expensive, but it is only used for the short distance where the speed is matter. But serial transmission is slower, but it is the less expensive as comparison to the parallel transmission. In asynchronous serial transmission, each bit of message is sent in the sequence at a time, and binary information is transferred only when it is available. When there is no information is to be transmitted, so the line remains idle. In this technique, each character consists of the 3 points. One is start bit, second is character bit, third is the stop bit. So the start bit is the first bit, which is always be 0 and used to indicate the beginning character. Second is stop bit, which is the last bit, and it is indicates that the end of the character, and it will always be 1. So the stop bit is always in the first state and frame the end of the character to signify the idle or the wait state. So the character bits, which are bits available in between the start bit and the stop bit, is known as the character bits. So character bits always follow the start bit and ends with the stop bit. This can be explained by the diagram. In this diagram, start bit is 0, so this will indicate the starting of the transmission. Here the stop bit, which is the 1, it means it is the end of the character, so after that no characters are available. So the characters or number of bits, ones or zeros available between the start bit and the stop bit is known as the character bit. So this is the asynchronous serial transmission. Serial transmission of asynchronous is done by the two different ways. One is asynchronous communication interface, and second is first in first out buffer. First method is asynchronous communication interface. Its working is depend upon the two main units. One is the receiver and second is the transmitter. So it works as both receiver and the transmitter. Its operation is initialized by the CPU by sending a byte to the controls register. So the transmitter register accepts the data byte from the CPU through the data bus and transfer to the shift register for the serial transmission. On the receiver portion, receives the information into the another shift register, and when complete data byte is received, it transmit to the receiver register. So the CPU can select the receiver register to read the byte through the data bus, or the data in the state register is used for the input and output flags. Second method is first in first out buffer. The first in first out buffer is the memory unit that stores the information in such a manner that first item is in the first two out. So the first in first out buffer comes with the separate input output terminal. This is the basically used, it can accept the data and receive the data, or it will send the data at different rates. So the main feature of this buffer is that it can input the data and output the data at two different rates. So when we place this first in first out buffer in between the two units, that is the source or destination unit, the first in first out can accept the data from the source unit at one rate and deliver the data to the destination unit at some another rate. So If the source is faster than the destination, the first in first out is useful for the data to receive the data in the buffer, and it is also useful in some application where the data transfer rate is asynchronously. Now the next topic is modes of data transfer. Data transfer is required between the CPU and the peripheral devices, memory or some between the two devices or two units. So to transfer the data from one unit to another, must be sure that both of the units have proper connection at that time, and at the time of data transfer receiving unit is not busy. So this data transfer with the computer system as the internal operation. As we all know, the internal operations in the digital system or digital computer system is synchronized by means of the clock pulse, which is generated by the common clock pulse generator. The data transfer can be of two types, synchronous or asynchronous. If we considering synchronous, that means both of the units are synchronized by some common clock, and they have a common clock to the data transfer rate. But in case of asynchronous, they have their independent clock and they are not synchronized by some common clock. When both the transmitting and receiving unit use the same clock pulse, then that data transfer is synchronous purpose. On the other hand, if there is not the concept of any clock pulse and sender operates at different movement than the receiver, that particular data transfer is called asynchronous data transfer. The data transfer can be handled by the various modes. Some of the modes using CPU as intermediate path, and other transfer data directly to and from the memory unit. So this can be handled by the three methods. First is programmed input output, second is interrupt initiated input output, and third is the DMA, that is the direct memory access. So first two method using CPU as the intermediate path, but third method, that is the direct memory access, is directly access the memory unit. First method is programmed input output mode. In this mode of data transfer, the operations are result in the input output instruction, which is the part of the computer program. Each data transfer is initiated by the instruction in the program. So the normally data is transferred from the CPU register to the peripheral devices, or from peripheral devices to the CPU register. In this particular method, the CPU remains all the time busy from starting to the end. So once the data is initiated, the CPU start monitoring the interface to see when the next transfer can made. So the instruction of the program keep close tab on everything that take place in the interface unit and in the input output devices. So CPU can't execute some another program during the execution of this programmed input output mode, because CPU is responsible for executing the data from the memory for output and storing the data into the memory for executing the particular mode. So this can be explained by the flow chart. In this flow chart, CPU execute the read or write command to the input output module. Then that is the input output module inform about the status of the CPU. Now we check the status of the CPU. There three cases can arise. Some error has occurred, or it can be busy. If it is busy, that means it will goes to the last state. If it is ready, that means the CPU can read the word from input output module and write it into the memory. Or second case, that CPU reads word from the memory and write it into the input output module. Then it will check the transfer is completed or not. If yes, then execute the next instruction. If no, then it will goes to the initial state. From this flow chart, it is clear that CPU remains in the execution of the input output instruction. So CPU can't execute some another program during the execution of this programmed input output mode. So the drawback of a programmed input output is, so the main drawback is CPU has to monitor the units all the time when the program is executing. So the CPU stay in the loop until the input output unit indicates that it is ready for data transfer. This is the time consuming process, and CPU wasted a lot of time in keeping eye of executing the program. So to remove this particular problem, we use second method, that is the interrupt initiated method. So it will solve by the some interrupt command. So second method is interrupt initiated input output. In this method, an interrupt facility or interrupt command is used to inform the device about the start and end of the transfer. So in meantime, CPU can execute some another program. So when the interface is ready, device is ready for the data transfer, it generates some interrupt request and send it to the computer. So when the CPU receives such a signal, it temporarily stops the execution of the program and the branches to the service program